So today is the last day of chemistry, last day of the mole equation. Tomorrow we will start unit 2, okay? And then Wednesday is your unit exam. So obviously anything I teach you tomorrow is not on the exam, okay? So don't study anything you learn tomorrow until the next unit exam, okay? I want you guys to give these ones a try. These were on the unit exam in like 2012 or something like that. So they're exactly like what you're going to see on Wednesday. All right, so looking at number 1 here, we're looking for the number of moles. So we are looking for N. And they tell us that we have 65 grams of water, so they're telling us the mass. And they're telling us it's water, which will allow us to get the molar mass. Okay, obviously water is H2O, okay, and that will be 1.01 times 2 plus 16, which is 18.02 grams per mole. Okay, so we got our molar mass, and all we have to do is find N. We don't have to manipulate the formula for that, so there's no algebra in this one. There's just a matter of plugging in 65 grams divided by 18.02 grams per mole. Whoa. 65 divided by. Okay. So we got 3.61 moles. Oh, not 36.1. Holy smoke, 3.61 moles. Struggle is real this morning. Okay. All right, questions on that one? Okay. And for the second one, we are looking for the mass. So looking for little m. They tell us what N is. There are 8 moles. Okay, and they tell us it's magnesium chloride. Now here's the mistake people make with this one. This should be a really easy one, but people do this and forget to do what? They forget to drop and swap, then they don't get the molar mass right, and they don't get anything else right either. Okay, so this is a +2, that's a -1, so we're looking at MgCl2, so that'll be 24.31 plus 35.45 times 2. (95.21 grams per mole is our molar mass. Okay, so now that we've got big M and N, we can solve for mass, little m, but we have to manipulate first. I need to move big M to the other side to isolate little m. Right now I'm dividing by big M, so if I want to move something, I do the opposite. What I do to one side, I do to the other. Okay, and then I've got my 95.21 times 8 moles. All right, so looking at 761.68 grams. Okay, questions on that one? All right, give you a few more minutes to get 3 and 4 done. So on number 3, we've got one of the ones that requires the extra step using Avogadro's number. What does Avogadro's number tell us again? Molecules in 1 mole, exactly. Okay, so we are looking for the number of molecules in this question. Okay, they tell us that the material is sodium sulfate, which is definitely going to need to be dropped and swapped. Okay, sulfate's a polyatomic ion with a -2 charge. Sodium is a metal with a +1 charge. So we're going to need a 2 there to make it work. Oh, it's sulfide, sorry. There. Now it looks better. Good catch. Okay, so we got sodium sulfide. That's going to be 22.99 times 2 plus 32.07. 7, right? Yeah, okay. All right, so we'll put those together. All right, 70 78.05 grams per mole. Okay, and they tell us that the mass, little m, is 200 grams. So I'm looking for number of molecules. Right now I have little m and big M, which means I can calculate the number of moles. So that's what I'll do. That'll be my next step. So that'll be 200 grams divided by 78.05 grams per mole. Okay, so we're looking at 2.56 moles. And I'm going to keep all those decimals in my calculator because I'm about to multiply by a ginormous number. Okay, so now that I have the number of moles, I can calculate the number of molecules because Avogadro's number is the number of molecules in 1 mole. If I multiply that by the number of moles, it will give me the number of molecules. All right, so we're looking at 1.54 times 10 to the 24 molecules. Questions on number 3? Okay, how many people have done number 4? All right, I'll give you a couple more minutes, then I'm going through number 4. So there'll be a few that I'll pick to go through, but for now, let's just get started on those. Okay, like I said, answers are bold, and bottom of page 13 in the workbook. I'll put up a slightly larger version here. Get to work on that. Okay, another thing. What's this stuff? Copper. Nitrate. No. Not 3.
Copper, nitrogen, oxygen.
No, nitrate's right. Copper nitrate is almost right. It's missing something. No, it's nitrate. I said copper nitrate is almost there. See, this is the problem. Almost everybody got this question wrong. Does copper have more than one possible charge? What was the first thing Coderre said for the first 10 questions? Roman numerals. I feel unheard. It's hurtful and bad for you. Okay. You don't want to miss this. Copper 1 nitrate. Okay. And also on this one. Seems to be with nitrates. I don't know why. Okay, what's that one? Lead 2 nitrates. Roman numerals. Guys, I guarantee you on the test on Wednesday, stuff like that is going to play a part. Okay, make sure you know when to use the Roman numerals. When do we use the Roman numerals, incidentally?
When they have more than one charge.
Right, when the metal has more than one possible charge. That would be lots of the things along the middle here. Okay, that would be things like chromium, manganese, iron, cobalt, nickel, copper. Okay, all of those things are, and lead and tin, okay, are other ones, okay, that are fairly common and have more than one possible charge. Please, please don't forget that on Wednesday.